the unseen universe, stepping into the atom. Everything you see is made of atoms. Look around, your chair, the air, even you. All are collections of tiny particles. These particles are called atoms. They are the basic building blocks of matter. Without atoms, nothing would exist as we know it. They are fundamental to our universe. Their study reveals the secrets of existence. Understanding atoms is understanding everything. It is a journey into the small. Imagine we could shrink. Smaller and smaller we go, past the familiar world, past grains of sand, past microscopic life. We are now entering a new realm. This is the domain of the atom. It is a universe within our universe, a place of immense emptiness and concentrated energy. The rules here are different. Prepare to witness the building blocks of reality. Our adventure begins now. As we approach a single atom, it seems vast. Mostly it is empty space, a strange and beautiful emptiness, like the cosmos itself. But this emptiness is not truly empty. It hums with potential. It is the stage for an incredible dance, a dance of fundamental forces and particles. We are moving towards its very center. This journey requires us to go deeper, deeper into the heart of matter. Our destination is the atom's core, a tiny speck in this vast atomic landscape. It is far away even from here, but we can see a faint glow. This glow emanates from the nucleus. The nucleus holds most of the atom's mass. It is the anchor of this subatomic world. We are about to witness its structure. The very essence of an element is found here. Let us continue our descent. The dense core journey to the nucleus. We have arrived at the atomic nucleus. It is incredibly small, yet it is immensely dense. Imagine a stadium. The nucleus would be a marble at its center. The rest of the stadium is the atom's space. This tiny core pulses with power. It is a cluster of even smaller particles. They are packed tightly together. This is the heart of the atom, its command center in a way. Here we find particles called protons. Protons carry a positive electric charge. Think of them as tiny plus signs. The number of protons defines the element. 1 proton makes hydrogen, 6 protons make carbon, 92 make uranium. Protons are relatively heavy particles. They give the nucleus substantial mass. They are crucial for the atom's identity. These positively charged particles are labeled proton. Alongside the protons, we find neutrons. Neutrons have no electric charge. They are neutral, as their name suggests. They act like a kind of glue. They help hold the nucleus together. Protons, being all positive, want to push apart. Neutrons help to counteract this repulsion. They add mass to the nucleus without changing its charge. These neutral particles are labeled neutron. What holds these protons and neutrons together so tightly? It is a force called the strong nuclear force. This is one of the fundamental forces of nature. It is incredibly powerful at short distances. Powerful enough to overcome the electric repulsion. The protons push each other away, but the strong force pulls them closer. It binds the nucleus into a stable package. This force is the source of immense energy. Whispers of energy, the electron's domain. Now let us pull back from the dense nucleus. We journey outwards into the atom's vast expanse. Here we encounter different particles. These are the electrons. They are much lighter than protons or neutrons. Electrons are in constant rapid motion. They exist in the space surrounding the nucleus. This space is not empty after all. It is filled with the activity of electrons. These particles are essential to chemistry. Electrons carry a negative electric charge. Think of them as tiny minus signs. Their negative charge is equal in strength to a proton's positive charge. This means atoms are usually neutral overall. The positive nucleus attracts the negative electrons. This attraction keeps the electrons bound to the atom. Without this balance, atoms could not exist. These negatively charged particles are labeled electron. Their mass is tiny, almost negligible compared to a proton. Electrons do not orbit the nucleus like planets, not in neat, predictable paths. Instead, they exist in regions called energy shells, or sometimes energy levels. Imagine layers around the nucleus. Each layer can hold a certain number of electrons. Electrons in outer shells have more energy. Electrons in inner shells have less energy. These shells are not solid tracks. They are more like zones of probability. The behavior of electrons is governed by quantum mechanics. This is the strange physics of the very small. We cannot know an electron's exact position and speed simultaneously. So, we talk about orbitals. An orbital is a region where an electron is likely to be found. Its path appears blurred. It is a cloud of probability, not a tiny ball on a fixed track. This is the quantum nature of the electron's dance. Quantum realities, the atom's true nature. The quantum world within the atom is fascinating. Electrons can jump between energy shells. If an electron absorbs energy, it can leap to a higher shell. If it loses energy, it falls to a lower shell. When it falls, it emits light, a tiny packet of light called a photon. This is how neon signs glow. It is how stars shine. These are subtle particle interactions, fundamental to light. This quantum motion is constant. The motion of electrons is truly bizarre. They are not just particles, they also behave like waves. This wave-particle duality is a cornerstone of quantum physics. It explains why their paths are blurred. They are smeared out in space. Their location is a probability. This is not because our tools are bad. It is the fundamental nature of reality at this scale. The universe is fuzzy at its core. It is a world of possibilities. So, let us recap our journey's findings. At the center, the nucleus. It contains proton, positive, and heavy. It also contains neutron, neutral, and heavy. Around the nucleus in vast regions of space, orbit electron. These are negative and very light. The protons define the element. Neutrons provide stability. Electrons engage in chemical bonds. These are the key players in the atomic drama. The atom, a tiny solar system, yet so much stranger. Governed by the weird rules of quantum mechanics. It is mostly empty space, yet it builds everything. From the simplest hydrogen atom to complex molecules that form life, all born from the interactions of these subatomic particles. Our journey into the atom reveals a deep truth. The universe is more wondrous than we can often imagine. From the smallest scales, the grandest structures emerge.